and I want to give you an update as to the recently released DNA results of the Paracas people. A total of 18 skulls was tested, and results came back from 12. The DNA was so badly degraded after 2,000 to 3,000 years. Now, it's taken us 5 years since we began this process to actually get the results.
For centuries, these skulls have baffled researchers. But now, with AI, the mystery is only getting stranger. Deep in Peru, archaeologists discovered elongated skulls dating back nearly 3,000 years. For decades, the question lingered: were these the result of ancient cultural practices or something far more mysterious?
No results were forthcoming. We're not sure if that's true or whether the results were so bizarre that they decided to hide them.
Recently, researchers decided to feed DNA from these skulls into advanced quantum AI. The outcome wasn't a neat answer, it was a warning. Today we'll explore what this experiment revealed, why the results are so unsettling, and what it might mean for the way we understand human history. Stay with us, because what we uncovered will challenge everything you thought you knew about ancient civilizations. The enigma of Peru's elongated skulls. Let's start with what we actually know. Deep in the coastal deserts of Peru lies one of archaeology's most puzzling discoveries: the Paracas elongated skulls. Peruvian archaeologist Julio Tello made an amazing discovery in 1928. A massive graveyard filled with the remains of individuals with the largest elongated skulls ever found. These aren't your typical ancient remains. We're talking about skulls that are dramatically different from anything else found in the Americas. The Paracas skulls have other unusual features and are the biggest elongated skulls ever found. Now, before we dive into the wild speculation, let's get the facts straight. Most experts believe these skull shapes were created through intentional cranial modification, a practice where cultures would bind infants' heads to create specific shapes. The results demonstrate that nearly all individuals, 98%, presented with ICM. That's intentional cranial modification. But here's where things get interesting, and frankly, a bit controversial. Some researchers have been pushing boundaries, conducting DNA analysis that has yielded some pretty shocking results. DNA tests of the Paracas elongated skulls revealed European and Middle Eastern origins. Wait, what? European and Middle Eastern DNA in 3,000-year-old Peruvian skulls? That doesn't fit the standard narrative of how the Americas were populated. This is where our story starts to get really fascinating, and where some people start asking uncomfortable questions about what these test results might mean. The scientific community is divided. Some researchers dismiss these findings, while others are quietly wondering if we've been missing a huge piece of the puzzle about ancient human migration and genetics. The DNA mystery that's baffling scientists. Let's dig deeper into what the DNA analysis actually revealed, because this is where the story takes a turn that even seasoned archaeologists weren't expecting. A DNA analysis has now been conducted on one of the skulls, and expert Brian Furster has released preliminary information regarding these enigmatic skulls. Brian Furster, who's been at the forefront of this research, has been making some pretty bold claims about what the genetic testing shows. The traditional explanation is simple. These were normal humans who practiced head binding. But the DNA results are telling a different story entirely. The enigmatic Paracas of the coast of Peru have not been the subject of many major studies, and the reason why may be because they do not fit with the standard story of the peopling of this area. Here's what's really throwing researchers for a loop. The genetic markers don't match what we'd expect from indigenous South American populations. Instead, they're showing connections to regions thousands of miles away, places these people supposedly never had contact with. Some scientists are suggesting this points to ancient migration patterns we've never documented. Others are wondering if there's something more unusual going on with the genetics themselves. The skulls aren't just shaped differently. Some researchers claim the DNA itself has unusual characteristics that don't fit standard human genetic patterns. Now, I want to be clear here. The scientific community is far from reaching consensus on these claims. Many mainstream archaeologists and geneticists remain skeptical of these findings. But the fact remains that someone, somewhere, has been conducting advanced DNA analysis on these ancient remains, and the results are raising questions that make a lot of people uncomfortable. Enter the quantum AI revolution. Now let's talk about the other half of this equation, quantum AI. In 2025, we're seeing an explosion in quantum computing applications, and artificial intelligence is at the forefront of this revolution. In 2025, the combination of artificial intelligence and quantum computing is expected to pick up speed. We're not just talking about faster computers here. We're talking about AI systems that can process information in ways that were literally impossible just a few years ago. Quantum computing could revolutionize genomics, with a focus on how it could speed up DNA analysis and advance uses of artificial intelligence in genomics. This isn't science fiction anymore. It's happening right now. Traditional AI systems process information sequentially, like reading a book one word at a time. Quantum AI can theoretically process multiple possibilities simultaneously, like reading every possible combination of words in a library all at once. When you apply this to genetic analysis, the implications are staggering. Quantum computing and quantum artificial intelligence, quantum AI, can be used to address the computational problem of biomarker discovery from genetic data. We're talking about AI systems that can identify patterns in genetic data that human scientists might never notice. But here's where things get potentially problematic. What happens when you feed quantum AI systems genetic data that doesn't fit normal human patterns? What happens when you give it DNA from these mysterious, elongated skulls? Some researchers are quietly exploring these questions, and the preliminary results are apparently causing quite a stir in certain circles. I say quietly because much of this research is happening behind closed doors, away from mainstream academic scrutiny. The unholy union of ancient DNA and quantum computing. This is where our story enters truly uncharted territory. According to some sources, and I want to stress that these are unverified claims circulating in research communities, quantum AI systems have been used to analyze the DNA from Peru's elongated skulls. The theory goes like this. Traditional DNA analysis can only look at genetic sequences in linear fashion. Quantum AI, however, can analyze genetic patterns in multidimensional space, potentially revealing hidden structures and relationships that conventional analysis would miss entirely. When quantum AI systems allegedly processed the elongated skull DNA, they reportedly identified patterns that don't match any known human genetic templates. We're talking about genetic sequences that the AI couldn't classify using its extensive database of human genetic variations. Now, before anyone jumps to alien conclusions, let's be rational here. There could be several explanations for unusual genetic patterns: ancient contamination, degraded DNA samples, or simply genetic variations we haven't cataloged yet. But some researchers are suggesting the patterns are too systematic, too structured, to be explained by these conventional factors. The really unsettling part, according to these unverified reports, is how the quantum AI systems reacted to this data. Some sources claim the AI began generating predictions and extrapolations based on the genetic patterns that were, let's say, concerning enough that certain research projects were quietly suspended. I want to emphasize, these are rumors and speculation, circulating in fringe research communities. There's no peer-reviewed evidence supporting these claims, but the fact that people are even discussing such possibilities shows how far we've come in both quantum computing and genetic analysis. The implications nobody wants to discuss. Let's explore what would theoretically happen if quantum AI systems really were processing ancient DNA with unusual characteristics. The implications would be profound and potentially disturbing on multiple levels. First, there's the historical implication. If the DNA from these skulls really does show non-indigenous origins, it would fundamentally challenge our understanding of ancient human migration patterns. We might need to rewrite textbooks about how the Americas were populated. Second, there's the genetic implication. If quantum AI systems are identifying patterns in this DNA that don't match standard human genetics, what exactly are they finding? Are we looking at genetic variations that have been lost over time? Ancient genetic modifications? Or something else entirely? Third, and perhaps most unsettling, there's the AI implication. Quantum AI systems are designed to learn and extrapolate from data. If they're processing genetic information with unusual patterns, what conclusions might they be drawing? What predictions might they be making about genetic possibilities we haven't considered? Some researchers theoretically worry about quantum AI systems developing genetic models based on non-standard DNA patterns. The concern isn't that the AI would necessarily do anything harmful, but that it might develop understanding of genetics that goes beyond current human knowledge, potentially in directions we're not prepared for. There are also ethical questions about using AI to analyze ancient human remains without proper cultural consultation. Indigenous communities have legitimate concerns about how their ancestors' genetic material is being studied and used. The scientific establishment's response. The mainstream scientific community has been notably quiet about some of these theoretical applications of quantum AI to ancient genetics. This silence might be strategic after all. Extraordinary claims require extraordinary evidence, and much of what we're discussing exists in the realm of speculation and unverified reports. However, there are signs that some researchers are taking these possibilities seriously behind the scenes. Academic institutions are quietly developing ethics guidelines for quantum AI applications in genetics. Research grants are being awarded for studies on the responsible use of advanced AI in archaeological genetics. The concern seems to be that we might be developing technological capabilities faster than we can develop the wisdom to use them responsibly. Quantum AI systems can process genetic data in ways we couldn't imagine just a few years ago, but we haven't had time to fully consider the implications. Some researchers worry about a scenario where quantum AI systems make genetic discoveries or predictions that society isn't ready to handle. This is particularly relevant when dealing with ancient DNA that might challenge established historical narratives or reveal genetic patterns we don't understand. The scientific establishment's cautious approach might also reflect concerns about public reaction to certain types of genetic discoveries. If quantum AI analysis of ancient DNA reveals patterns that challenge mainstream understanding of human history or genetics, how would society react? The unverified claims and wild speculation. Now we enter the realm of pure speculation and unverified claims that are circulating in certain research communities and online forums. I want to be absolutely clear. What follows are rumors, theories, and speculation, not established facts. Some sources claim that quantum AI analysis of the elongated skull DNA revealed genetic patterns that the AI classified as non-human or unrecognized. Again, this could have mundane explanations like contamination or degradation, but it's allegedly caused concern in some research circles. Other unverified reports suggest that quantum AI systems began generating genetic reconstructions based on the skull DNA that didn't match any known human genetic templates. The AI allegedly tried to fill in the gaps in the ancient genetic data by extrapolating patterns that might not apply to human genetics. The most extreme claims suggest that quantum AI systems processing this data began making predictions about genetic modifications or enhancements that were theoretically possible based on the patterns they identified. This allegedly led to ethical concerns about AI systems developing genetic modification theories without human oversight. Some conspiracy theorists have taken these unverified claims and run wild with them, suggesting everything from ancient alien genetics to time travel. But even setting aside the wildest speculation, the core concern remains. What happens when advanced AI systems process genetic data that doesn't fit our current understanding? These claims remain unsubstantiated, and mainstream science hasn't validated any of them. But they highlight important questions about the responsible use of advanced AI in genetic research. The ethical minefield. Even if we assume that most of the wild claims about quantum AI and ancient DNA are speculation, the ethical questions raised by this technology are very real and very serious. First, there's the question of consent. Ancient human remains belong to cultures and communities that should have a say in how their ancestors' genetic material is studied. Using advanced AI to analyze this DNA without proper cultural consultation raises serious ethical concerns. Second, there's the question of interpretation. Quantum AI systems might identify genetic patterns that human scientists can't verify or understand. How do we responsibly handle genetic information that goes beyond current human knowledge? Third, there's the question of application. If quantum AI systems do make genetic discoveries based on ancient DNA, how should those discoveries be used? Should they inform modern medical research? Should they influence our understanding of human evolution? The field is moving so fast that ethical frameworks are struggling to keep up. D-Wave released a new open-source toolkit that lets developers use quantum computers to help train AI models, focusing on machine learning. But with great power comes great responsibility, and we're not sure we're ready for that responsibility. Some researchers are calling for moratoriums on certain types of quantum AI genetic research until proper ethical guidelines can be established. Others argue that the potential benefits are too important to delay. The elongated skull DNA controversy, whether real or imagined, serves as a perfect case study for these ethical challenges. It combines sensitive cultural materials, advanced technology, and potentially paradigm-shifting discoveries in a way that highlights all the ethical complexities of modern genetic research. The future implications. Looking ahead to the rest of 2025 and beyond, the intersection of quantum AI and genetic research is only going to become more complex and potentially controversial. We're entering an era where AI systems might make genetic discoveries faster than human scientists can verify or understand them. This creates a fundamental challenge. How do we maintain scientific rigor and ethical standards when technology outpaces human oversight? The theoretical scenario of quantum AI processing unusual ancient DNA highlights broader questions about the direction of genetic research. Are we prepared for AI systems that can identify genetic patterns we can't explain? What happens when AI makes genetic predictions that challenge our understanding of human biology or history? Some researchers are quietly preparing for scenarios where quantum AI genetic research produces results that are too controversial or complex for public release. This raises questions about scientific transparency and who gets to decide what genetic discoveries are shared with the world. The elongated skull controversy, real or imagined, might be a preview of future conflicts between advanced technology, ancient mysteries, and established scientific paradigms. As quantum AI becomes more powerful and accessible, we're likely to see more situations where technology reveals patterns or makes predictions that challenge conventional understanding. Whether the specific claims about Peru's elongated skulls and quantum AI are true or not, they represent the types of challenges we'll face as technology continues to advance. We need to develop frameworks for handling genetic discoveries that might be uncomfortable, controversial, or paradigm-shifting. So there you have it, the fascinating, controversial, and largely unverified story of Quantum A. By potentially analyzing Peru's mysterious elongated skull DNA. Whether you believe the claims or dismiss them as speculation, one thing is clear. We're living in an age where ancient mysteries and cutting-edge technology are colliding in ways that challenge everything we thought we knew about genetics, history, and the capabilities of artificial intelligence. The real question isn't whether these specific claims are true. It's whether we're prepared for the types of discoveries that quantum AI might make possible, and how we'll handle genetic revelations that don't fit our current understanding of human history and biology. What do you think? Are we on the verge of genetic discoveries that could rewrite history? Or are these just modern myths, born from our fascination with ancient mysteries and advanced technology?